Hi, I'm Ian Cluster, and today I'll be talking about composing the network with streams. So computers are very powerful playback technology. Instead of just playing back a fixed composition as a sequence of notes or samples, they can run the steps necessary to generate a piece of music. So composition can be a field of possibilities rather than a single outcome. Now, the difficulty in using this is that it's hard to work with dynamic materials like randomness or like external data in real time. It's hard to write something into a composition when you don't know quite what it is ahead of time. And it's difficult to combine aleatoric elements with structure and form and fixed materials. Today, we're going to talk about an abstraction we think is very well suited to this kind of composition, streams. So within the Internet of Things, the need has been articulated for new forms of composition to meet the challenge of composing the network, and that's what we aim to address here. We're using the abstraction of streams, common in functional programming, like in Scheme and Haskell, often without side effects and with memoization. And of course, our work's related to the existing music programming languages out there, with the difference that it relies on streams rather than the typical signal flow graph. So there's three kinds of composition you can work with. There's sequential composition, saying first this will play and then that will play, writing notes horizontally. There's parallel composition, saying these things will happen at the same time, like writing notes vertically. And then there's functional composition, which is like applying transformations to something. So saying, I have a guitar, it's connected to a distortion pedal, and then that's connected to a reverb. That's functional composition. And the pairs of these correspond to familiar abstractions. So the signal flow graph is great for functional and parallel composition. That's what it directly represents in the graph. The DAW timeline is great for sequential and parallel. That's what the horizontal and the vertical are. And the linear pipeline, as in Unix, is great for sequential plus functional. But each of these abstractions is missing one of the three kinds of composition. So for instance, the DAW timeline doesn't have functional composition. The effect chain is a thing outside of the timeline. And the signal flow graph doesn't have a sequential composition. So you need either a separate score or some separate interface for modifying the graph. Now, streams support all three. And a stream is just a thing that can give you either a next element in the rest of the stream, or it can just say, the stream's over, that's it. So it's a recursive data type. The rest of the stream is itself a stream, and that continues until you reach the end. Now, aleatoric streams aren't memoized, so if you try again, if you call again, you might get a different result. So maybe this keeps going if you try again. And streams support all three forms of composition, as you'll see in a minute. And unlike the signal flow graph, the stream graph has its changes built in. So when a stream ends, that affects a change in the graph automatically. They mesh nicely with network streams, as you'll see in a second. And with that, here's a demo. Let's see how we can use Aleatora. I'll import the library, turn down the volume a bit, and then we can start creating and playing streams. So tone would go on forever, but we slice it. Since it has an ending, we can then sequentially compose it with another stream, like this. We can also compose it in parallel, like this. And we can compose it functionally. So this is tone, but I can map a function onto each of its elements, and then it gets quieter. Now let's bring in some external resources. So I have two WAV files that I would like to use in my composition. So I load them, convert them to streams, and then we can call a stream function on them. Flip creates a new stream that randomly picks between the streams it was given.
Sample B.
So we got sample B that time. Now I'm going to loop this chance stream.
Sample B. Sample A.
So the second iteration through, we got sample A. And that's because each time through it actually reruns the stream with a potentially different result. Now I'm going to use service over the network. So we have this Wikipedia module. It's a third-party module that can get us random Wikipedia titles, and then we can use that in a stream like so.
2011 Green World ATP Challenger. Clara Bryant Ford. Sharkovsky's theorem.
So those were 3 random Wikipedia titles that we made audible through stream operations. And now I'm going to do something with the local network. So my phone is running an OSC client that I want to use in a composition. It's sending orientation data. I want to convert that to frequencies. So I can do that like this. And then if I tilt my phone, that affects what's going on the composition on my laptop. And we can also go the other way. So if there's something interesting going on my laptop in a composition there, and we want to send it to the phone, we can do that. So we create the socket, and then we just need to add a side effect to the stream of frequencies. So each time a frequency pops out of the stream, we will send it over to the phone, which is listening using Netcat on port 8000. So we do all this. We have random frequencies playing, and then the phone knows about them. That was a glimpse of how you can use Aliatora to compose the network. The source is on GitHub. It's in an early stage, but we have a lot planned, so please try it out and ask questions. Thank you for watching.